Good morning, everybody. Welcome. I'm very excited to see so many diehards attending TechX 300. Instead of going for a normal 100 or 200 session, let's dive deep into this technology. And today I brought you a story about our VMware Private AI Foundation offering and the technology that will affect you managing your infrastructure. My name is Denneman. I am the Chief Technologist for Machine Learning, but I'm also the, let's turn this one on, technology. But I'm also the lead architect for VMware Private AI Foundation, which we announced at Las Vegas Explore. Now, what we're trying to achieve with this platform is a way for customers to easily build, fine-tune, and deploy generative AI models. Not only that, we can also do it with machine learning, but the green part is the NVIDIA software that allows you to easily create models or download models and make them your own. Now, when we're talking about generative AI, what we see is a lot of cool stuff. For example, everybody can create an artistical picture with just text. One of the cool presentations that I saw was from Katerina. While I'm always showing diagrams and boxes, she decided to use Midjourney to create all these fantastic elements that portrayed certain traits and certain problems within your infrastructure. And I thought that was a brilliant move to provide a different view of things. And this technology allows everybody to create something with just words. So if we look at the top left one, you can actually use an input and describe it. And I think it's not clear in the back, and it's not clear for me to read it out, but it was a steampunk rhino with a top hat and glasses and dust and all of that stuff. So you're using words to create a picture. We call that input. A data scientist calls this prompt engineering. And so another thing what's interesting is that data scientists will come up with new terminology every week, and in many cases it's quite bloated. So if you hear about prompts in engineering, it's just about figuring out the way to interact with a large language model in the most optimal way. Now, this is something that most of you have seen already. By show of hands, who used ChatGPT? Okay, basically the whole room. This caught the attention of the whole world. And every business is now trying to scramble with ideas to make it theirs and to improve their business, either to increase the sales motion or to decrease the cost. And so we see a lot of our customers trying to come up with solutions that uses a form of generative AI. So text-to-speech is a very interesting one. Intelligence agencies are grabbing a lot of these wiretaps and letting them to transform it into text where you can do search and where you can do analysis. We have customer services where you launch a new technology and you will have a large language model with a chat API in front of it, or chat application, to allow the customer agents on the phone to type out the questions. Or in some cases, they're actually linked. So the customer asks a question that is speech to text, and that is automatically inputted into the large language model, and the call agent will get the right answer. So the cool part is that the person on the phone will have more focus on the actual customer without scrambling to figure out which system to use and how to figure out where the information lives, because it's just presented on their screen. Language translation is a very interesting one. We can think about from Danish to Spanish or from English to Dutch, but think about the language that an engineer talks and the language that a salesperson listens to. Those are two worlds apart. And with a solution like this, you can actually make a environment that allows salespersons to basically use the information that the engineer provides in their own language. The last one is very popular, codecs and copilots. I think a lot of you already listened or used Copilot, and we are doing the same thing internally. We've developed SafeCoder together with Hugging Face, and it's available on GitHub as well. And what we've done is we looked at all of our code, and we've got million lines of code which we created over the last 25 years. But the thing is, we can do the analysis of all of those lines, or we can identify the top engineers and look the way they code their programs, their applications. So we identified what we call 10x engineers. We used their code. We trained it on a foundation model, and I'll talk a little bit about foundation models in the next slides. And we fine-tuned it with the dataset. The dataset was only 70 megabytes in size. So it took us roughly 4 hours on an A100, an NVIDIA A100 GPU, to fine-tune that particular model. And now every engineer in the company, when they write code and when they log on to SafeCoder, they can just use the code, they can start with coding, and then they can use tab to auto-complete it with the way our 10x engineers do it. And so we enhance the engineers across our company. Now, the thing is, with this, are you using a public large language model, or are you using it or creating it on-prem? Now, nobody signed off internally to push our code to a public LLM, a large language model, because that's our IP. Nobody trusts the large language models enough today that they'll say, I'll trust it with my crown jewels. So we have internally a policy that restricts us from using ChatGPT. Anybody in this room also have that same policy? Yeah, already a few. And so how do you still ride this wave of technology, but still comply to your policies? And so this is the concept of VMware Private AI Foundation, because a lot of our companies, our customers, they have to deal with privacy laws, right? We cannot, or they cannot, put that data out, or even the model, in an external facing environment, because the model that is trained on the data will actually show the data to anybody that will engage with that large language model or that other model. Another one is trustworthy data. If you now go on to ChatGPT, you will see all the results from up till 2021, and it's trained on web crawl for 70%, and 20% is Reddit threads. Reddit threads with more than 3 likes. Think about a financial company that uses that model for their own financial things. You're actually using a model that's trained on Wall Street's bets. Seriously, I hear Richard laugh, that is the last thing you want to do as a financial company. So you want to ensure that the model will actually use the technology and the data that you trust. Third one is confidential data, like the SafeCoder example. We don't want to expose our crown jewels to the rest of the world. And the compliancy reasons typically is pretty much the same. For example, the federal government of the United States, they can use cloud, but they cannot use a cloud service that is shared with other companies. So they cannot use shared infrastructure. You can see a large language model as an infrastructure. because a lot of these people train on that model, they ingest data, it's trained on that data, and so there is no clear distinction of that environment. So when we're talking about foundation models, this is the, how can I say this, cloud-like way, or maybe we can call it a hybrid AI environment. Companies like Meta and like Microsoft and Google have created these large language models and trained on a lot of the data which I just discussed. And so they did the heavy lifting, and they created this generic model that generalizes and knows everything from Wall Street bets to the migration path of humpback whales. And so what you want to do is you want to start create it into a specialist focused on your domain-specific data, solving your specific domain, your specific business challenge. And the key element is that foundation model. That's your starting point. So, oh, sorry, I already skipped this. So one of the most frequent mentioned one is Llama 2. Llama 2 is a foundation model that rivals ChatGPT. But the cool thing is you can download it from Meta itself and start to create it or fine-tune it into your own little thing. DALL-E 2 is a something like Mid-Journey, gives you the same capabilities. GPT-4 is of course the big one that's out now, and you can actually use it when you pay for a license, when you basically pay a license fee. And then of course there's the OG of it all, that is called BERT. Now, if we look at the foundation model that Meta exposes, Llama 2, they trained this model with all that data. And it took them 196 GPU years, and it exposed or expelled 291 tons of carbon dioxide. So if you're dealing with ESG metrics, this is a great way of actually dodging that, because they did the heavy lifting for you. They trained that model, and you can consume it, and you're not dealing with the years of training and exposing all that CO2. Now, when we dive into that 196 years, Meta created this supercomputer, which is called Meta RSC. And in that system, it contains more than 6,000 GPUs. So if you divide that 196 GPU years over the number of GPUs, we're talking 282 hours. 11 days of continuous training of all these models. So you just need to hope that nothing breaks and everything stays up. That's a feat by itself, right? So for those type of training, we understand that you do bare metal. This particular thing where you're going to do this once every 6 months or once every year, a designated environment makes sense for bare metal. But this is just a use case. This is fine training the model. The model by itself is just a small cog in the entire application landscape. You need to use software to expose the model. You need to run the model. You need to have an application that actually allows customers to use the model. And these are typically run on the same platform. Do you really want to use a bare metal silo for that? Or do you want to continue and use your VMware environment? Now you know my answer. You want to use the second one, of course. So let's talk more about foundation models. Now, a lot of this misconception appears when we're starting to talk about Hugging Face. Hugging Face is the internet repo, the most dominant internet repo for all the foundation models out there. Just create an account, download the file, expose it to the data scientist. The data scientist will fine-tune it to their likings, and then you can deploy it and expose that model to an application. One of the misconceptions that Robbie and I typically have when we're talking with customers is that customers think there's a communication between Hugging Face or a cloud service and the model itself. That's not the case. A foundation model is just a file which you download, and then it's up to you how to use it, and it won't communicate with any cloud-like services. Now, I mentioned fine-tuning quite a lot, but there are different ways of fine-tuning. The first one is prompt engineering, and that is just the art of creating the best question which you can ask to a large language model. And there are a lot of data scientists that are only doing that, figuring out a way to create a template for an application to use to get the best answer. Sometimes you can actually use it with ChatGPT as well. You can give it a question and an answer 5 times and then ask the question which you really want to ask to ChatGPT. So you're training it into a particular mode, and then it will answer in the same way. This is what you call prompt engineering or few shots. If you want to use that, that's the lowest TCO. You just need to have a data scientist coming up with the right template and you're good to go. You don't have to retrain or fine-tune a foundation model. You just have to run it and do some prompt engineering. Now, the biggest challenge is tuning. And so there are many different ways of tuning. There's speed tuning, there is called PEFT, parameters efficient fine-tuning, and the last one, reinforcement learning with human feedback, is the most difficult one. That's where you allow real humans to basically grade the responses of your model, and so fine-tune or let the model behave differently. The one that this is the highest TCO, because you need to have knowledge, you need to have data scientists, but you also need to run the models and push a lot of data into that model to actually get it to a shape or a state that you really like. The next one is what I believe is going to be the most popular one. That's retrieval augmented generation, short RAG. And RAG allows you to use what's called a vector database. It's a database that vectorizes text, and it creates an environment where you just can upload your documents and have the chat application use the vector database to do some prompt engineering on the large language model. So in essence, you're chatting with documents. And so this is a great use case for customers that go through, well, a renewal of services or creating new types of products and have the customer service engineers or employees answer those questions right away. So typically what you need to do is you need to fine-tune your model every time you launch a new product or a service. But with RAG, you just upload your documents into that vector database, and then automatically you can ask the questions to your large language model, and it will receive the latest updated information. So how does that work? So here you have that client application, and we're going to ask the large language model for a particular solution. So in this case, I ask what's new in vSphere 8 Update 2. So prior to the Las Vegas Explore, we built an entire environment with the components you saw on the screen. So we created a large language model, we downloaded Llama 2, and we attached a vector database, and we put in new documentation about vSphere 8 Update 2. And so we wanted to test whether all the software that NVIDIA exposed to us was actually making sense and they were working, and we needed to figure out what the challenges are for our customers. So we created that environment, and so the client application asks to the large language model, what's new in vSphere 8 Update 2. But instead of going directly to the large language model, it is hit by a query encoder, which will send it to the vector database, where we have all these new documents loaded in. And so the query is passed to the vector database. The vector database will find similar types of text, and it will actually send it back to the client application, and it will augment, it will add the responses out from the vector database into the prompt without the user actually seeing it. And so the next step is actually sending that enriched prompt, that prompt with your original question and with the added text, into the large language model. And now the prompt will say, I've got all of this information for you. This is my question. Please generate an answer I can understand. And that generated a response will be sent back to the application, and from that you can read that vSphere 8 now supports up to 16 vGPUs, like Richard so kindly shared with us. So the tuning of the models is actually a far more efficient way than training it. Like you see with Llama, with Meta, it took them 196 GPU years. We fine-tune typically 1 to 2 days on a couple of GPUs. So how do you know what your infrastructure looks like or what you need? And so let's talk a little bit about sizing of the GPUs. So when we look at the whole model world, what you can see with the orange line are the models focused on vision, like detecting a license plate, figuring out what text there is, all of that stuff. And you can see that the vision models, they started in 2012 and they continued to 2021. There's still newer creating one, there's newer that are created, but overall the environment or the vision models are pretty much in a good shape. The dots you see are the number of parameters inside a model. And what you can see is that there's this upward line. Now the blue line are the NLP models, the natural language processing models. And you can see they're way larger because language by itself is a very complex construct. The red line is the timeline of the GPUs that can support these models with the number of memory capacity. So what you can see is that if I want to run a model like inference, so we're actually serving it, most of the popular models cannot even fit inside a single GPU. The majority, like the Llama 2 70 billion model, so it has 70 billion parameters, is simply not runnable on a single GPU. Of course, there are multiple Llama models with lower parameter count, but this gives you an idea of what do I need to present to my data scientist. And so there's this metric for that. That's called bits per weight. And so when you train a model, you use a particular precision, you use a data type. And the most common one is FP32, floating point 32 bits. Now a floating point 32 bits, one parameter consumes up to 4 bytes. So that means if I have a billion FP32 parameters, that means I consume 1 gigabyte. That's the easy way of calculating it. There will be some additional memory consumption, but that's basically what the easiest way of determining whether you can actually run a model on a single GPU. So what you see, the 7 billion model could be run as inference, deploying it and exposing it to the world on a single GPU. But what if I want to fine-tune it? Now, one of the most popular fine-tuning methods copies the parameters in FP32 and it stores it again in FP16, floating point 16, which is half, of course, which takes 2 bytes. So that calculation means 7 billion times 4 bytes is 28 gigs, 7 billion times 2 bytes is 14 gigs, so that's already 42 gigs of memory, and then I need to push data into it. And you want to push as much data into that device as possible, so you reduce the training time. So what you can see is that if I train it with LoRa, which is one of the fine-tuning methods, I actually need 2 L40Ss. Now what's an L40S? That's a new device from NVIDIA that has 48 gigs. So we need to already think about an infrastructure that consumes or allows you to have room for two GPUs that has double PCIe slots. So a normal 2U box is not cutting it, right? Because there's no 4U PCIe slots in that. If I go with a larger model, the 13B, I need to have the double amount of GPUs. Another way of dealing with this is buying a GPU with a larger memory capacity. Does this make sense? Yep, cool. So when we're dealing with the infrastructure, which we run in containers, we need to actually download some of the software. And the most common one is the Triton Inference Server container, which you can download from NVIDIA Google Cloud, and you can run it in your environment. But the thing is, it actually is in a compressed state 6 gig. That's not common what most people think when they hear containers. They think a couple of megabytes, maybe 100 megabytes, but not gigs, not 6 gigs. If you look at the NeMo framework, NeMo is the software that allows you to fine-tune a model and to prepare your data set and to apply some guardrails. And a guardrail is a piece of software and guidelines that allows the large language model to behave in a certain way, not to answer certain questions or to react in a negative way. And that's roughly 10 gigs. But here's the thing, you typically need a few versions of it, or you're figuring out which version do I want, and I want to store it somewhere else. I want to store it on-prem because I'm dealing with a lot of privacy here. So if you want to upload it to your Harbor repository, it is actually decompressed before you can tag it, and then you can upload it into your repro. So that means we're dealing with more than 20 gigs for a container. That's typically not the normal size for a Harbor deployment. So you have to change your Harbor deployment as well to have it, let's say, 1 terabyte worth of repository. Now another thing is that trying to run that and trying to start that, it takes a lot of heavy lifting for a Kubernetes environment. It typically doesn't start in a second because it has to load, it has to set it up. So it takes maybe a minute. Most DevOps engineers will freak out, like, why isn't it working? It's working, but it will take some time. Now, I heard Katrina say that's so true. Exactly, right? Now, another key thing, when we're thinking about containers, most of the VMware people are already conditioned to say, oh, container, that's Kubernetes. In data science world, that is not the case. The case is most data scientists don't want to deal with Kubernetes. They don't want to deal with infrastructure, but they don't want to deal with Kubernetes because what they're typically doing is batch style jobs. They're preparing something, they're pushing it into an infrastructure, and then they wait for the result, and then they basically look at the result, analyze the result, and then they'll do it again. There's no need for fancy orchestration whatsoever. So the majority of data scientists, they use containers as interactive containers. Just have an Ubuntu virtual machine with Docker installed, the NVIDIA Container Toolkit, and they're off to the races. It becomes interesting for the service aspect, deploying a model that you expose to the applications that are in production. That's one way you want to deal with these environments. But here's the thing, the data scientist will not convert it into a service, and the majority of ISVs, independent software vendors, are not providing any tools for you to do so. So you need to figure out how you can actually transform that interactive environment into a service-like environment. This is your biggest challenge, outside finding GPUs at the moment, but this is your main concern. So going on to the size itself, models itself are beasts. They are taking up to 13 to 40 gigs of memory space. Data scientists will download a lot of models to experiment on, to figure out. So you need to have an environment that will provide that data capacity as well. You also need an environment that can actually version it, that allows them to tag it and to figure out, okay, I've used that for that particular experiment, but this is the model which I'm going to use for fine-tuning and expose it into my application environment. So think about those metrics as well when you create an environment for them. Otherwise, you'll go back and you need to add more data capacity, and that goes on and on and on. It's a never-ending story. So when we're dealing with GPUs, I already mentioned, like, this is a two PCIe device. But it starts with power. The majority of your systems running in your data center, they typically have normal power supplies. But these will consume a lot of power. So the recommendation is get the fattest PSU in your system. So my lab runs 2000 watt PSUs, double, to basically run a system with 1 or 2 GPUs. Getting it into the system is a challenge by itself, finding the space in the system, but then it needs power cables. That is a mystery for most companies, for the companies like Dell, HP, but also for NVIDIA. I was lucky and I got 2 H100s, the latest version, from NVIDIA. And I said, I'm going to run it in that type of server, so send me the power cables. NVIDIA, sent 4 times the wrong power cables. And so if they don't even know it, well, good luck with that. So one of the recommendations that we have is there are accelerated certified servers, which you can buy from Dell, HP, Lenovo, and they have these devices equipped already. That is the fastest way, it's the fastest path to get started, because you got this certified environment ready to go. Now, the other one that I want to talk about is, let's say you have multiple GPUs, right? And I need to get one more back. If I have 2 GPUs, I can use NVLink. And the NVLink is a communication path directly between one GPU and the other GPU. If I'm running a training or a fine-tuning that involves multiple GPUs, they will want to communicate with each other. And they do this very frequently. So you want to have the fastest path between those devices. These 3 bridges on these machines will give you almost 900 gigs of bandwidth. That is insane, and it's actually something you really want. But the challenge is, it's a plastic device, so you cannot do anything about it or with it. So you need to have that room inside your server environment. So one thing that NVIDIA came up with is called the HDX system. It's the equivalent of a DGX system, but it's not branded by NVIDIA itself. It's just a main board with the GPUs inserted in the main board itself. So you don't have PCIe devices, you have just chips soldered on the motherboard itself. Alongside that is a NV switch, which is a fabric that exists between those 8 not PCIe devices, SMX devices. And that will give you the best performance possible. Now, what we do with VMware is we say, maybe you don't need all these devices, all these 8 GPUs for a single workload, but you want to basically distribute the resources amongst different workloads. And so what we provide is what is called a device group. What we identify the topology of the main board, we understand how they're connected, and then we can say to the VI admin, or we can expose it to the VI admin, ways to provide the GPUs in the best way possible. So you can create a virtual machine and hope it's legible, but with 2 GPUs, or with 4 GPUs, or with 8 GPUs. And that's presented as a single block. You just select 2 GPUs, and it's configured automatically for you into the virtual machine. Or if you want to consume the entire box, you will just take 8 GPUs. Now, if you want to look at this from a diagram perspective, what you see here are the GPUs, and they're all connected to multiple switches. Now, this is the best thing. The moment we load data, and typically we load data from the system RAM within a NUMA node, we needed to get it onto the environment, right? But there's a lot of communication going on during the fine-tuning and the training. So what we do is the moment, or actually what the HCX system does, the moment it is transported into the memory of the GPU itself, it stays there and it won't hit your CPU again. So you completely offload your interconnect of your NUMA nodes. This will create the best performance within the system for the machine loading workload, but it will also allow you to consume your server for other workloads, because this is not a noisy neighbor from a CPU perspective anymore. This is the best way forward. However, it is not cheap. So you can imagine that a single A100 is list priced at $12,000 to $16,000. This typically is roughly starting at $200,000 to $300,000. So I don't want to make you really happy, like I want to buy 5 of them, because that's a different story with your CFO. Now the last lesson that I want to leave you with is model serving. And that's where you're going to make money, or you're going to reduce cost with the model itself. And so you need to have an inference framework. And I created a diagram of the Triton inference server. And so you expose the API of the model to your application, and you can send a question, a prompt to your model, and it will receive an answer. But the cool thing is, and I won't go over the entire architecture, is that you attach it to a model store. And that can be an NFS share, that can be an S3 bucket, or that can be something else. The moment the data scientist will store that fine-tuned model in that model store, it's automatically transferred into the inference server and loaded into the Triton inference server to get it exposed to your application. So that is a very interesting way of automating things, or to attach it to a particular pipeline. The thing that you need to figure out is, okay, how do I expose an NFS backend or an NFS data store, or maybe an S3 bucket, to this environment? That is something that you need to figure out. If you want to scale up, it automatically scales up if it needs more resources, depending on the number of GPUs that you actually attach to it. And with the upcoming version, the NVIDIA AI Enterprise 4.0, they will have actually a manager that can actually scale up multiple Triton inference servers at the same time. I think I spend a lot of time on this, so I'll stop here. If there are any more questions, I'm here for the next 2 days. If you want to learn more about this, Robbie and I, here he is, we'll have another session today, Ask Me Anything, and I have a session with Johan and Jits from NVIDIA to talk more about this as well. But if you see me walking around and you have questions, just ping me. You can basically talk to me. But if you don't have the opportunity and you will have some questions, ping me online. with the addresses that you saw. And with that, I would like to thank you.